So hey y'all, I'm Julian. I'm going to be talking about coroutines in Android and how they can clean up your asynchronous code. So quick, like I said, I'm Julian. There's my Twitter handle, my email address, my cat. I work for a company called Fix Automotive. I'm one of the co-founders. We are all about helping drivers better understand and better maintain their cars. And so we have a suite of products to do that. And one of the products that we have, the main product that we have is the Fix sensor. So it's a diagnostic Bluetooth sensor that plugs in the diagnostic port of your car. It talks to our app and it tells you if you have a car problem come up, it'll tell you what's going on. It will remind you about regular maintenance, all that good stuff. So we've been using Kotlin at Fixed for about just over a year now. We started with just tests, and then when 1.0 came out, we started adopting it and writing a lot of code in it. And we've actually been using coroutines more or less since the beginning. So we've had this talk is the culmination of a year of coroutines in production on Android. And I want to talk about first why I think coroutines are a better way to handle your async code than some of the other existing solutions that we have. And I'm going to do that by kind of giving an example use case and then doing some comparisons of different kinds of code. And then show you coroutines, give you an idea of how they work, and then dive into some Android specific use cases that you could apply to your actual code. And then a couple of pitfalls that we've also found so that hopefully you can avoid those. And feel free to stop me at any time if you guys have any questions. So first, what I see is the biggest problem in software development is that I/O is hard and that everything useful that you want to do is I/O. Now, by I/O, I'm using that term loosely to mean anything that interacts with the real world. So you can have some beautiful functional code that separates your that's a nice flow of data, or you can use object-oriented code and have this nice architecture. But at some point, your code has to touch the real world. It's got to make network calls, or access the file system, or draw something on the screen, or listen to touch inputs or sensor inputs from the phone. And that's all the stuff that actually makes your app do something useful. But I/O is really hard. It's fragile. It's intermittent. It takes a while usually, and so that boundary is what's really hard in software. Now we've known about that for a long time. We've been trying to solve it a lot of different ways. Of course, there's multi-threading. You just spin up threads to handle blocking code. There's async task, which I don't think really anybody in Android uses anymore, but that's one solution. You can have callbacks. So I think everybody's pretty familiar with callbacks. And then there are other abstractions that kind of build on top of callbacks. So really, futures and promises and reactive streams like observables like RxJava are all just fancier APIs on top of what's really just callbacks under the hood. And so, but how good are these at actually solving async problems that we see day to day? So I've got a little example here. Let's say you work for a social media company and the boss comes to you and says, all right, I want a page in the app that fetches the user's list of friends from our system and then cross-references that with their contacts list and tells them how many of their social media friends are in their contacts, right? Pretty simple. And so you think about it a little bit, you think about all the edge cases, you draw up a flow chart that looks something like this. So, can you guys see that? So, I've drawn the blue. Anything in blue is kind of this I/O boundary, right? It's like some sort of async task that can take a long time. potentially fail often. And then the orange are like the UI states that your app can be in. So maybe this is what you print to the screen, for example. And so what we're going to do is we're going to like tell the user that we're doing something because it's going to take a little while. We're going to go fetch, we're going to make a network call, get their list of friends. Of course, network calls can fail, so if it fails, we're going to pop a dialog, say, hey, you need, like, we couldn't get an internet connection, do you want to try again? If they say no, we'll just like tell them that we couldn't do anything and sorry. But if they want to try again, we'll just keep retrying the network call until it succeeds, right? Eventually, hopefully it succeeds, in which case on Android we have all the new permissions, newish permission stuff that we have to deal with. So if we don't have permissions, we need to ask for them, and that takes a while to get a response back. And they can say no, and so if they say no, then we can just error out and say you didn't give us permissions, right? But if they say yes, finally, now we can read the context, do the comparison, and draw what we actually wanted to draw, right? So I made this example kind of long to really highlight the benefits of coroutines, because like if all this was one network call, it's a little harder to see what the benefit would be. But like this isn't a terribly complicated flow. Like I imagine most people's apps have a flowchart on certain pages that is like worse than this. I know we do. How can we actually implement this? So before I go to how we can implement this, here I've got just kind of a toy interface of recreating this flowchart in just imperative code. So I'm using an interface to kind of fake out methods that I don't want to actually write the implementation for, but we can assume that these methods are implemented, right? So can you guys read this? Should I zoom in a little bit?
That's better.
Not good. So what we're going to do is I'm using a text view to represent like actually drawing something to the screen, right? If you had more complicated UI, you could do it here. So we're gonna write to the screen. We're going to load our friends, and if it fails, we're going to ask them if they want to retry, and if they do want to retry, if they don't want to retry, then we'll error out. We're going to do all this in a while loop, so it'll keep trying until the value succeeds, right? And then we're going to get the permissions. We're going to error out if they refuse to give us permissions, and finally we can actually do what we came to do, right? So it would be awesome if we could actually write the code this way, but we can't, right? Because you can't run network calls on the main thread. You can only access the views on the main thread, and then stuff like this, like getting whether the permissions are granted or not, comes back on an on-activity result or an on-permission result or whatever. So it's a callback, and so like this can't write code this way, unfortunately. So what do we do? Well, I think most people's Android code looks something like this. This is how you would solve the problem. So I made a kind of fake activity here. So somewhere like on start, for example, you would start this process. You'd write, you'd set the thing up. You'd write your, oh, here we go. Is that better? You'd start your network request. And here I'm using like retrofit, but you could use any like networking library you want. You probably use something similar, and so you'd set callback, so when the network request succeeds, then you'd move on to the next step, which would be like checking permissions, right? And if it fails, then you can go to this retry dialog. You'll pop the dialog, and if they want to retry, then you end up going back to this first function and starting over. Otherwise, you kind of just error out and let the task end, right? And then you move on to check permissions, which can either like search the contacts. If you are on an old device, we can just go ahead and search them. If not, we have to check. And if you have them, we can go ahead and search them. Otherwise, we're going to have to receive, get the response back from the permission result, and then finally we can do it, right? So this works. It's not blocking the main thread. It wasn't that hard to write, but it's a little hard to read. So what happens is you've broken all of your steps into like individual functions, right? So if the boss comes by later and says that you need to add some step into this flowchart, you have a lot of opportunity to break stuff, right? Because you don't know if you've put stuff in the right spot in your flowchart. Plus, there's nothing stopping you from accessing friends here before the network request has succeeded. There's nothing stopping you from calling search contacts if you haven't already gotten the permission. So it's easy to break stuff with a flow like this. And so I think most people, that's kind of where the whole view model pattern has come in, where you separate your business logic from your activity and so on, right? So let's say you want to build you want to get to a more view model pattern where you've got your business logic in one place, kind of separated out from this. And so you're sitting there and you're thinking, okay, how can I get this where everything is in like one linear block, but without blocking the main thread? And so one idea you might have is, okay, well, let's just start another thread and block that one, right? So here's an example of this. I don't recommend you actually do this. This is just for example purposes. So I'm going to start a new thread. Anytime I want to do something on the user interface, I'm going to have to call it back over to run on UI thread, which is gross, but it works. Now I can do my while loop, and I can run my network request here because I'm allowed to block this thread, no problem. That's fine. The problem is when we get to callbacks from the activity, now you're kind of screwed, right? The way I implemented it here, which I don't recommend you do, is I used Java objects wait and notify methods. If any of you are familiar with Java threads, there's definitely a few better ways to do that, but they're all kind of really gross, right? Like, you don't want to be doing this in your real code. We can do better than this for sure. And so one idea is callbacks. So here I've changed our async methods to instead take in a callback, which returns, it's a lambda which returns either an exception or a list of friends when the network request succeeds. And then our contacts takes in the friends and eventually returns a list of contacts in our callback, right? Same thing for the retry dialog and the request permissions. Like, there's a way that we could bridge activities to accomplish this. And so instead what we're going to do is, now we're back on the main thread, so we can update the user interface. We can call our load friends. Now I've made this load friends with retry function, which has tried to make this recursive while loop using callbacks. Good luck trying to read and comprehend that or support it after you wrote it and you came back and wanted to use it again. Like, maybe you could make some sort of helper method that recursively calls your callbacks for you or something like that. Some like really generic form of this that you can reuse, but that's not great. Let's not do that. But at least the other problem is we've got callback hell here. So inside of load friends, now we call request permissions, and inside of that we're actually calling 3 layers deep. We still had to break our method up into 2 steps unless you want to copy and paste this logic in 2 different places. So that's not great either. It's getting better. It's better than threading, but it's still not great, right? There are other things. A lot of people now love RxJava. RxJava is capable of doing a lot of this stuff. Let's see what that example looks like. So I've changed load friends, search for contacts to return observables of these things to represent future values. I guess these could be singles as well. It's the same concept, right? And somehow I've mapped my activity methods to also return observables. And so let's look at the actual code. It's like, okay, well, it's not that long, but it's very dense. And if you actually drill into this, so we're going to load the friends. We need to set up a retry, and we're going to retry after showing the dialogue. We need to know whether they said yes or no. And so here we do a flat map to convert the result of the retry dialogue to, so apparently, according to the documentation of retry when, it retries if you omit anything, but it doesn't retry if you complete or error. And so we're trying to hack together by throwing an error here to tell it to not retry. Then we use flat map to chain the result of friends onto the next step. So who here isn't really familiar with RxJava, hasn't done a lot with it? I have a fun game for you. Find somebody who does a lot of RxJava and ask them to describe flat map to you. It's everybody will kind of struggle to explain the concept. And so with observables, to chain processes sequentially, you have to use flat map. And a lot of times you'll have to nest flat maps. So within, after we've loaded our list of friends, now we have to request the permissions, and then we sub flat map in to search for the contacts, and it's just really gross. Now, and then of course, we have start with has to come at the end. So if we want to start with the loading state, then we have to put it at the end, which is terribly hard to read. Now, one of the nice things we did is I've put this subscribe down here, but you don't have to do the subscribing here. I was trying to be representative of, you've separated the logic that generates your UI states from the actually updating the user interface, which is nice. That's a nice clean separation, but at the cost of this functional programming mess that is super hard to read and maintain, right? And I'm sure there are ways to break this up into things that are a little more readable, but ultimately you're gonna have to teach your junior developers RxJava and learn flat map and continue to support this for long into the future, right? So before I show you coroutines, I want to quick recap. So if you just break everything into functional steps, it's easy. It's hard to read and hard to maintain because it's hard to follow, right? Callbacks, you have callback hell. It's hard to refactor. There's also problems with cancellation. So one thing that happens in a lot of the demonstrations that I've showed you, not in the observables, but basically in all the others, is there's no way to stop the process. So if the user quits your activity and then your process keeps on running and tries to access the views, you're going to get a nasty crash, right? So that's no fun. Promises and futures can solve this problem, but completable future is only available in version 24 and higher, and I think that means that pretty much everybody in this room can't use it unless it's a personal app. The other problem is that futures are concurrent by default. Particularly futures and observables are kind of both concurrent by default. So what I mean by that is it's easy to run things in parallel. It's hard to run things in series. And most of the things that we want to do are running things in series, right? You can't do the contacts operation until you have the list of friends. And then observables, there's a steep learning curve. You've gone from writing imperative code to writing functional code. There's a lot of operators to remember. And now I want to show you this same kind of example implemented with coroutines. So what have I done? I've changed my async methods to just have this suspend keyword in front of them. That's all I did. And then my example now is identical to the imperative code that I wrote originally. I'm just going to update the text view, load the friends. I can do this while loop. I can show the retry dialog and get the value back to say whether they want to retry or not. And what it's done here is it's put these little squigglies, these little squiggly arrows here, wherever I've called one of these functions that are marked as suspend. And so this is super cool. This doesn't block the main thread, except that we can still update the text views. So what's actually going on here? So what happens is the main thread, we start on the main thread starts executing, we update the text view, and then it gets down to this load friends network call, right? And what happens is the network call starts, and then the main thread stops execution right here, but it doesn't block. It goes back to doing all the normal main thread stuff. It's drawing frames, it's listening for touch events, it's just looping through all of the things that gets put on the run on main thread loop, right? And then as soon as the network request finishes, it says it drops. It tells the main loop to say, hey, next thing to do is to come back right here. And so the main thread picks right back up, takes the value that it got from the network request, keeps on executing down until it gets to the next suspend call. And then again, it opens the dialog box and then goes back to doing its normal thing. And then as soon as somebody presses yes or no in the dialog box, it can come right back here and keep on executing. So it lets you write code that is way easier to read and support and change, and also not break Android. So that's coroutines. Coroutines simplify your async because you can write things cleaner, easier. Now, before I have to tell you this before I move on any further, is that coroutines are still technically an experimental feature. Some of you are going to be like, no, like definitely not going in production. But what do they mean by experimental? So the API is stable, or the code is very stable. There are not many, like it's been out for a year now. There are no real bugs. What they mean by experimental is the API hasn't been finalized. So what happens is they've been pushing out a lot of minor or like patch releases where they'll deprecate methods and change APIs. But they've guaranteed backwards compatibility, and all the calls that I'm going to talk about in this talk are pretty stable and not likely to change. And the other thing is Kotlin's made by JetBrains, who also makes Android Studio. So any changes that they can make it really easy to do migrations from older versions to new versions. So even if you use a method that's going to get deprecated, it's easy to migrate as changes occur. So can you use it in production? Roman Elzarov, who's the guy behind coroutines at JetBrains, he says, yes, you should, and I agree. So how do you get started? So the suspend keyword is part of Kotlin, but everything else with coroutines is installed through a library. The idea is eventually it will be part of like the standard library, but right now it's an add-on library. So you'll need to install the core and the Android library, and then if you use RxJava, or if you use like completable features or NIO, which are like newer Java 8 features that most of us can't use yet, there are bridge libraries for all of those as well. So you can convert observables to coroutines and back and that sort of thing, right? What's the overhead? So ours, this is a cool plugin, by the way, if you guys don't know. There's this dex count Gradle plugin that on your build, it will generate this lovely breakdown of method counts. So like here's our package, here's the Android support library, and then coroutines is right here at 800 methods after ProGuard for our library, or for our app. So, and our ProGuard settings aren't all that tuned yet. So I'm sure it could even be less. So it's really light. So how do you actually create a coroutine? There's this, so when you install a library, there's this suspend coroutine keyword. So what this does is you're basically bridging callback formats into coroutines. So this suspend coroutine function, it takes it passes a continuation as its argument, and that's how you can call back and resume the calling thread. So I did this new thread, thread.start, thread.sleep as an example, but don't actually do this. There are better ways, obviously, to do threading stuff, but just as an example. So what will happen is when you call delayed parseInt here, immediately this thread will get created, and then the function will continue, and then the calling thread will suspend at that point and go on to do other stuff. And then eventually, when the thread has finished sleeping and it's read the result, here we call continuation.resume to pass the result back. And so that will wake back up the calling thread and allow it to continue on from where it left off. We can also call resume with exception if we had an error, like number format exception, for example. And what that will do is it will cause the thread to resume, but throw an exception right there at the call site. So it looks like your function threw or returned, because essentially it did. Coroutines are combinable just like any other function. So if a function's marked as suspend, it can call any other functions marked as suspend. And you can use all the normal flow control. You can do if statements. You can do while and for loops. If you prefer map, filter, reduce, you can do all that stuff. As long as your function is marked as suspending, you can write it just like any other normal code. Unfortunately, then, you can't just call a function marked as suspend from regular code. You have to kind of bridge the two worlds. So the way you do that is through a coroutine builder. The most common one is launch. So launch here, it takes in a context, which I'll talk about in a minute. And inside that block, now you can call all the functions marked as suspend that you want to. And what it does is it returns a job, and that job kind of represents, it's similar to a thread in concept, so that you can control the operation, but it's not actually a thread. So these coroutine contexts, so the concept, there's actually kind of a couple of concepts that are all baked into coroutine context, but the one that's most important is where you want your code to actually run. So there's a couple of places you can do this. The most common ones for us are UI is one that represents the main thread on Android. So if you just want to run stuff on the main thread, you can use UI. Common pool is a thread pool that coroutine creates. So it's just like a pool of background threads that if you want to run something off thread, you can put it in there. You can also create your own contexts, like a single thread or a fixed thread pool, or like if you have some sort of crazy place that you want to run stuff, like you can create your own context and pass those in as well. But pretty much you're only going to use UI or common pool, I imagine. So coroutines, the cool thing about coroutines is they're sequential by default. So you can call this first function, it'll suspend, and then it will resume before you call the second function, right? And most of the time, that's exactly what you want. But sometimes you do actually want to run stuff in parallel. And so if you want to do that, there's a way. You can use the async await keywords, or not keywords, functions. So in JavaScript, async await are keywords. In Kotlin, they're actually just implemented as functions, right? So async is a coroutine builder that takes in a context, just like launch. In here, we can call whatever methods we want. And what it does is, instead of returning a job, async will return a promise. It's actually, in Java world, it's called a deferred. And so it's a promise of an integer in the future, right? And so if we create one of these promises and then we create another one, then now we can call await on each one to suspend until that promise finishes, right? Now both of them will launch immediately. As soon as we call async, they'll start, and then when we call await, we'll just suspend until they finish. And so this should take 100 milliseconds and not 200 milliseconds. You can think of coroutines as lightweight threads. This is the kind of silly example that the coroutine people love to give. That if you tried to launch 100,000 threads, you would have a really bad time. But you can totally do that in Kotlin. Not that you really have any need to. Here I'm using join, which is a function on a job to say suspend this job until, or suspend my job until this job finishes, or suspend until this job finishes. And so that way we can wait for all of these jobs to finish before continuing on. Coroutines are cancelable with a big asterisk, which I will talk about at the end. So you can, if you have a job, you can just call job.cancel, and it will it'll interrupt your coroutine, and you can stop what it's doing.
Can you pass anything with that, like some kind of something?
Yeah, so you can actually, so by default, you pass it just throws a cancellation exception, but you can pass your own subclass of cancellation exception if you want to tell it exactly why you're canceling. You can do that. How they work under the hood, I think this is an awkward example. I won't show this to you. I think I have a better example in my example code. I guess this is the same, but what this suspend keyword does is what it does to the equivalent Java code under the hood is it adds another argument to your function. It adds a continuation argument. And so that is kind of it's essentially a callback is all it is. It's kind of your bridge between the whole system it sets up and the eventual coroutines. So Kotlin's going to add this coroutine argument to your function, and then what it's going to do is when your function runs, it's going to basically make a case switch statement or a go-to statement to jump down to the step that you're on, right? So the context or the continuation will tell it which step you're trying to return to. So the first time it's just the first step, but you can skip ahead after subsequent suspensions, and it can contain all of the properties, all of the state that all the variables that you've created previously, and then pluck them back out and continue execution from there. So that's all it does under the hood. It's not magic. It's just creating a state machine inside your function for you in Java code. So that's introduction coroutines. Before I move on, any questions about coroutines in general? Cool. So some practical Android use cases. One is anywhere you have an API that uses callbacks, you can wrap them up and turn them into coroutines. So here I'm using suspend coroutine on task, this is the Google Play Services task that you get back from location provider and all that stuff. A lot of that stuff uses tasks. And so we just add a complete listener to continue and a failure listener to resume with exception. And now we can just call task.await here. We can do last location.await and suspend until we have the location. So that's pretty cool. If you install the RxJava bridge library, now you can convert back and forth between observables and coroutines if you have a lot of code in observables. So you can call await on singles, await first, or await last on observables. Everything works the way you expect. So if you if your observable errors, it will throw like a coroutine. If you cancel your coroutine, it will unsubscribe from the observable. So it's a nice, clean, complete API there. One pattern that we love is the confirmation dialog. So here I'm using suspend cancelable coroutine. So that allows us to define a coroutine that's cancelable. So what we're going to do is we're going to create our dialog. We're going to set the positive and negative buttons to call coroutine.resume. If they cancel, we're going to cancel the coroutine. And if the coroutine is canceled not by the dialog box, but by the job getting canceled, like we close the activity or whatever, then we're just going to close the dialog as well. And so now you can just call a function to show a dialog and get the answer back. Activities can be done the same way. This is messy. Let me show you a better example of that. If you want to start an activity for a result, now you can suspend until you get the result. So the example code that I have here, we have something similar in our code base. We define a data class to represent the result of the activity. We do the request code, the result code, and the intent. And then here we're using a publish subject to accomplish this, but I'm sure there are other ways to do this too if you don't use RxJava. And we create a publish subject to capture all of the start activity for result calls. So whenever onActivity result gets called, we'll just dump an activity result object onto that publish subject and make sure we clean it up on destroy. And then we can define this start activity for result async function, which is marked as suspend, and all it does is start the activity for result and then await the publish subject until it gets a response that was the request code that you asked for, and returns that object for you. So now you can, if say you have an activity that pops a form that they need to type some values into, you can wait for them to fill all your form out before you, and collect all that data before you can continue on. Which is really cool to be able to treat activities as functions in themselves. If you got blocking code like SQLite or file system access, and you don't want to do that on the main thread, you can wrap that up too. Here I'm using the async coroutine builder and just running it on the off thread. Now we didn't actually suspend here, but it doesn't matter. We're just blocking the comment pool for a little while, and main activity main thread can continue on until this comment pool thread ends up finishing and returning the result, right? Now jobs, you want to make sure that they don't keep running beyond the life of your activity, right? So one way to do this is just keep track of any jobs that you launch and just make sure that you cancel them on stop or on destroy, like at the right lifecycle callback from when you created them. This is a simple example. It's just like keeping a reference to the job. In my repository, which I'll share at the end of this, I have a deeper example that's based on what we do, that it's got some helpers to keep track of multiple jobs and when they need to start and stop and get cleaned up and all that stuff. Testing coroutines is super easy too. There's this run blocking coroutine builder that blocks the calling thread until the coroutine finishes, which you don't want to do in real code, but on test it's perfect, right? Because now you can run all of your coroutines sequentially, make your assertions, and then let the test finish. Now, a couple of things that we've discovered over the last year of doing this. One is it's still asynchronous code, or it's still multi-threading and stuff like that. So anything that is a problem in multi-threading, you can still accomplish with coroutines. For example, race conditions. If you Like this will definitely not do what you want it to do. If you're trying to mutate state from two different coroutines, it's still going to create race conditions. The other thing is you should really cancel jobs, especially if you, like you should always cancel jobs, like bar none. I can't think of a case where you would want to let a job like go off into the blue because you have no idea when the activity or when your app's going to get closed. So if you do this, you're going to get a nasty illegal state exception because they quit your activity, but then you go and edit the views anyway. So instead, just keep a reference to the job and cancel it at the right lifecycle call. There's a few more cancellation gotchas that are less obvious. So one thing is cancellation is also not magic. It's just implemented with an exception. So when you call job.cancel, it goes back to the point that you suspended and it throws a cancellation exception. So if you do something like this where you catch an exception, you just caught your cancellation exception and your coroutine keeps running even though you called cancel. So that's a little tricky. So instead, catch cancellation exceptions or be more particular about the exceptions that you catch. The other thing is that cancellation is cooperative. So what that means is it's you actually have to build the cancellation on the coroutine side. It's not just magic. You have to actually provide some sort of cancellation implementation. So all of the built-in coroutines like delay are cancelable, and all of the bridge libraries like the RxJava bridge libraries are cancelable. But if you write your own coroutine and you use suspend coroutine instead of suspend cancelable coroutine, that isn't cancelable, and so it's just going to keep running even if you call cancel on it. And like this, the Google Play Services task doesn't have any way to cancel it, so we don't really have a choice on that. We have to like make it be a non-cancelable coroutine. Now, like retrofit, for example, does allow you to cancel calls that are still in progress. So that one we could write a bridge that's actually cancelable. Also, if you don't, cancellation can only happen at suspension points, right? So if we have a coroutine that doesn't ever suspend, it just runs a bunch of blocking main thread code or blocking thread code, there's no point for it to suspend to check and see if it's canceled or not, and so that's not going to suspend. That's not going to cancel either. So there's a whole lot more to coroutines. You can implement the actor model. You can they're like channels. There's like asynchronous generators and stuff like this. If you're familiar with Go, there's an equivalent of Go routines. That's their it's similar to their channels. There's some cool like multi-threading things like suspending locks and stuff like that. There's lots of cool stuff. So I will get you all the links for all that stuff. Before I do, one last pitch. We are a growing team, and we're always looking for talented people, not just Android development, not just engineers, but just anybody. If you are interested, hit me up. There's my email. And then some resources. So the Kotlin, the main Kotlin library has a great README of a whole bunch of examples, more examples than I've given here. Also, Roman has an intro talk from last year that's really good. He's also got a couple of talks from Kotlin Conf a few months ago, I think, that go into a little more depth. So if you're curious about how they work under the hood, there's a great video for that. And then all of my example code and then a few more examples are on this GitHub repo. I'll share all these links out on the Slack. I need to join the Slack first, but then I will share all these links out on there. Great. So Any questions about coroutines? Hey, David.
Hey, Julie, do they interact well with Java? Say, I've got this massive legacy app.
That is a great question. So I have an example. Here's a little example. Oh gosh, what am I? There it is. Here we go. So I've got a little foo suspend function that eventually returns a string. And then I've got a job factory basically that calls launch and returns a job, and deferred, which returns a deferred int, right? And this returns a job. So in Java world, you can't call foo directly, right? Because if we try this, foo here is going to take in a continuation because it's added this continuation argument to our function, right? And we don't know how to create those. We'd probably break stuff if we try to create one. So don't recommend you do that. But you can interact with jobs and deferreds. And there's also future builders. If you want to return a future, you can do that as well. So I can call job. I can check if a job is active. I can cancel it in Java. I can also get a this should be a string, shouldn't it? I can get a promise as well and check and see if it's completed yet, and then await the result. And so those, generally speaking, in Java, you probably want to use some sort of bridge to a traditional Java thing rather than calling the coroutines directly. Either create an observable or create a future or promise or job and interact with those. And so there is some interopt, but you can't call suspend functions themselves.
Excellent, thank you.
Any other questions?
So y'all are using this in production already?
Yes.
Were you using RX before, or?
Yeah, so one thing that we're still trying to figure out, and I have some ideas on this, but I would love to talk to people because we're still trying to figure it out, is how to really implement a nice view model pattern with some of this stuff, right? Because you can create your controller and do everything in coroutines there, but when you want to call, like if you want to call that dialog launcher or something like that, like now you're putting some logic in the activity and some logic elsewhere. So we've got a couple of ideas of how to deal with that. Yeah, so we were using RxJava, and we still have a decent amount, and so we're kind of bridging everything together. But we've been slowly kind of converting over. Like, it's really easy to convert over if you had a function that returns an observable. Like a lot of our view models all just convert that to a coroutine anyway. They just call await on it, and so then you just convert it into a suspend function, and it's two-line change.
Nice.
And so
that was actually, I was going to ask a similar kind of question.
Sure.
Like, I've been wondering, I guess I really fell in love with RxJava because it gave all the things that we wanted. And now it feels like, my gut feels like it's gotten a little bit too complicated for its own good. And, like you say, too many operators. Do you foresee coroutines replacing RxJava as a way to handle, threading model on Android? Because it seems like, there's certain things in RxJava that, are done really well, like back pressure and handling that kind of problem, or like, the error model in the example you gave with the throwing the error and the catching and gotcha and all of that. And that works really well on RxJava, right? Like retries and all that kind of stuff. So, I mean, what do you think? Will they exist in tandem, or will a coroutine flavored RxJava come out? Or what do you think will happen with that?
It's hard to say. In my mind, I think we'll kind of figure out what I hope and what I'm trying to do at Fixed is figure out a framework that lets us use coroutines in place of RxJava, but maybe that's too maybe that's just not possible. So we'll have to kind of see. But
I think a lot of people are thinking that, like secretly wanting coroutines
Right.
to replace RxJava, even though RxJava was such a godsend, but now it's become this kind of laborious thing to work with, right?
Exactly.
And we want the features built into the language.
Right.
But like even the task of like building a like transformer, observable transformer implementation with this would be crazy. So, you know, because it has at least some conventions figured out or agreed upon.
Right. And like I could see there being you define your coroutines, and then under the hood for really hard problems like retry or something like, or buffering, then you just actually just call an observable under the hood and then await it, right? And that's a pattern that we've been using so far, and it's been fine. So, but I do await the day that I can. We haven't bothered to convert to RxJava 2 yet, because I'm hoping to
Now all
just
the
use coroutines
flavors,
instead,
yeah,
right?
And now all the flavors of different observables, and the fact that those don't quite work the way that
Exactly.
everybody thinks that they should. And
Yeah.
yeah, like you say, it's too complicated at this point. So yeah, I feel like we need some kind of reactive coroutines kind of thing. That'd be
Well,
really
so as someone who never wanted RxJava because it never made sense in my brain, and this did, like we were talking earlier that the biggest advantage this has is how few keywords there are for you to learn to really start to take advantage of it. Like the barrier to entry is so much lower that, especially like you were talking earlier about junior developers, and like now you have to teach them this whole thing so they understand 10
Right.
lines of code. And it's like no one wants to do that. Versus coroutines, you teach them 10 lines of code to give them access to everything. It's like, you know, it's touching the stone in that sense. And I think I do think that there will be more things built around coroutines that feel like what those complicated cases you were talking about, as people start to dive into them and don't want to use RxJava anymore, but there's still that complicated case.
Another example that I thought of was a lot of the complicated logic you can wrap up in an extension function, right? So let's define a new inline function that does this. I think we have a exponential backoff coroutine builder or function, right? So you give it a coroutine block, and it just while loops and delays longer and longer while it retries, right? And does the exact same thing, and it's also way more readable, so that if you were like, how is this exponential backoff thing work? Well, then you drill in, and there it is. So I think it's going to take a while for us to convert a lot of those cool observable tools to coroutines, but it won't take long. Or, I mean, we'll figure it out eventually, so.
I am fairly new to Android,
Mm-hmm.
and in full disclosure, the first time I heard coroutines was in the meetup invitation. So,
Yeah.
so pardon my question, and you can choose to answer it offline if you want. So I understand that Kotlin is an alternative to Java, right? And so your organization fixed completely went to Kotlin.
We're
So
like, I think
Java,
we're,
or you have a combination, and how did you decide that to use Kotlin?
yeah, so we, I had heard about Kotlin in the early days. I wanted to give it a try, and so we started writing some unit tests in it. It's like, wow, it's so much nicer to write, right? Maybe one day we can switch to this. And then we were working on a major architecture change just as 1.0 came out, and we were like, all right, well, 1.0, that's probably pretty stable. And so any of the new code that we were writing for that architecture change, we went ahead and wrote in Kotlin. So there's there's probably 5 to 10% of our code that's still in Java that we just haven't gotten around to converting yet. But all of our new developers pick it up really fast. Especially if you already know Java, it's so fast to pick up Kotlin.
Thank you.
Yeah.
Sync activity for result. How does that handle death?
So yes, that's a great question. So on destroy, we just here using published subjects, we just call on completed, which will cause it to return a canceled activity result, which in theory would probably keep your coroutine running, right? But your activity probably on destroy also canceled your coroutine, and so hopefully your coroutine isn't running. But even if it did, it got a canceled activity result, and you probably quit your coroutine anyway. So. Cool.
All these threads are running under the same process?
Yes.
That process?
Yes.
So, okay, because I was thinking about the process death situation, but that doesn't matter, because it's.
Yeah.
Is there any strange warnings and whatnot when you start up on this that you didn't see before, or like I tried to run one and maybe I'm not doing it correctly, but I got that some warning about the main thread was too much work was being done on it and whatnot. And I mean, is there anything new that happens, like before and after?
I don't think so. Sometimes it's hard to know exactly where your code is running. The coroutine launchers try and make that better, but it's not always intuitive. But one of the things another coroutine benefit over observables is you define where in your coroutine launcher you define where you want your code to run, and you don't ever have to worry about like subscribe on, observe on, like jumping back and forth between threads and stuff. It just runs on the thread that you actually wanted it to run on. So
have you run into any issues where a stack trace might not say where the coroutine was awaited, or?
I think there are a few tricky things, but most of them are because observables messed up the stack trace, right, and not because coroutines. The coroutines, it generates the JVM will generate your function with a couple of extra lines and arguments in it, right? So you can still jump to the line in your code where the error actually happened. And I believe the stack trace, if say one of your coroutines resumes with an exception, the stack trace there will be in the place of where you resumed and not in where you threw the exception. I might be wrong about that, but I'm pretty sure.
Okay.
I have another question. So you probably laugh when I ask some of this stuff, but so like I come from old school days when we used to have to write our own thread pools. We didn't really provide that stuff for you.
Yeah.
So like one of the things I know RxJava has, I can actually create my own scheduler, and it can be based on my own threads or my own thread pool, depending on what it is that I want to do. Is there anything in coroutines that lets me control what thread it's running on at that level?
Yeah, so you can write your own coroutine context or coroutine dispatcher or something like that. It's a simple interface. I don't remember it offhand because I try and avoid doing the real threading stuff, right? But there's a mechanism to do that. Yeah.
You can like pass it an executor.
Yeah, that's another way to do it. If you have an executor, you can just create a context from an executor. Awesome. Anything else? Thanks, y'all.